set up the things here. Okay, so can you see the whiteboard?
Yes.
Okay. Okay, so determinants. So as usual, I will be solving some examples for the determinants, and with those, with the solution of those examples, I will also explain. So determinant is basically a number corresponding to a matrix. Okay, so we have a matrix. Okay, so we have a matrix, and then corresponding to that matrix, there is a number. Okay, or a scalar or whatever you can call. So that will be that is called as the determinant. So for each matrix, we can calculate its determinant by following certain methods. So we start from a 2 by 2 matrix. So for example, or maybe even for a, if for example, if you have a matrix has just one number, okay, one component A, okay. So its determinant will be represented by determinant of A, and that will be, if there is just one number, so that one number will be the determinant of A. Recursively, then we can say that the determinant of a matrix with four numbers, that is for a 2 by 2 matrix, okay, A, B, C, D. So remember that we can calculate the determinant for a square matrix, okay, for a square matrix. So any other matrix which is not square, we cannot calculate the determinant. So determinants are only for the square matrices. So for example, now for the determinant of a 2 by 2 matrix will be represented by this. So we can do this multiplication in these directions. So the first multiplication will be with the plus sign, the second multiplication will be with the minus sign. So this is the rule for the determination for a 2 by 2 matrix. So then in this case, it will be AD minus BC. So that will be the determinant of A, okay? So if we apply this rule, then the determinant of this matrix will be 2 minus 1, 3, 1. So the determinant of A will be then 2 times 1 minus 3 times minus 1, or minus 1 times 3. So it will be uh, 5. Okay, so determinant of A will be 5. And if we have a matrix like A, 6, 2, 3, 1, so its determinant will be 6 times 1 minus 2 times 3, so it will be 0. So determinant can be 0, can be a negative number, okay? So any values are possible, okay? The determinant of a matrix. Okay, so these were the determinants of the 2 by 2 matrices. The determinants of 3 by 3 matrix can be also calculated by similar methods, but of course there are some rules which we need to follow. So for example, if this 3 by 3 matrix is 0, 1, 0, 4, 2, 1, 3, and then 0, 4, minus 1. So if we want to find its determinant, then we can find its determinant by a certain approach. Okay, so that approach will call for the consideration of the row elements. Okay, so what I mean by that is that, so for example, in this case, the method is something like this: determinant of A will be then the sum of some terms. So we will start from this first element of the first row. Okay, so we will start from 1. So this first element of the first row will be 1, and then it will be then the determinant of times the determinant of so for example, if I take this 1, then I will remove this term 1 at this row 1 and column 1, and what will be left is what will be left is 1 3 and 4 minus 1. Okay, so that sub matrix I will take from here. Okay, so I will take this sub matrix. Okay, and then the next step will be we have to go alternatively, plus, minus, and then I will take the next element, which will be 0 in this case. So in this case, for the 0, then I will for the 0, I will remove this column and this row. Okay, and the whatever will be left, that will be 2 3 0 minus 1. So 2 3 0 minus 1. Okay, and that will be, we will find its determinant, and then plus, minus, and then again plus. Okay, so it will be then 4 over here. So in this case, now I will remove these first row and the third column, and then what we are left with will be then 2 1 and 0 4, 2 1 and 0 4. Okay, so in this case, now we have expanded this 3 by 3 matrix for finding its determinant into 2 by 2 3 2 by 2 matrices. So our answer will be, for the determinant, will be given by this expression. Okay, by this calculation. So let's move this. So actually we can calculate it, but before we calculate it, we call these smaller matrices are the minors. Okay, so these smaller matrices are called as the minors. Okay, these smaller matrices. So this minor, the minors are represented by this symbol M. So this will be the minor M11. M11. Why? And this will be called as the M11 because this minor is corresponding to the first row and first column element, and this will be the minor M12 because this matrix will be related to the first row and second column, and this will be the minor M. Can you tell me what we should call it? What we should call it? M what?
13.
Yeah, M13. So these are the minors. So M11 is this matrix. Okay. M11 is then 1 3 4 minus 1, and M12 is 2 3 0 minus 1. So can you tell me what will be M23? What will be
1004?
1004, like this?
I guess.
Okay, so I need to check it. So M23, so 2 means second row and third column. Yeah. So Yeah, 1004. Yes, correct. Yes. So these are the minors, okay? And these factors which are being multiplied over here, these are called as the cofactors. So these are called as the cofactors. So we can call them as C11. Likewise, C11 is then +1. C12 is then 0. And C13 is the +4. Okay. So that is the cofactor. So cofactor is actually determined by this formula. So cofactor, so for example, if I want to cofactor co-ij, Cij, so it is determined by this formula. So it is I plus j, uh, um, sorry, it is minus I plus j, so power 1, okay? That is minus I plus j power 1, okay? So it will be, that means over here. So minus I plus j power 1. So it is, for example, for the first one, it is, and then it will be the aij. So minus I plus j power 1. So for example, for the C11 is then aij, that is this term, but then that term is to be multiplied by I plus j. I is 1, j is 1, 1 plus 1 is 2, minus, so it will be 2 power 1, okay? So it will be +1. No, it is power I plus j, okay? Yeah. So it will be, okay, I just did some mess up over here. Let me correct it, okay, the formula. So again, I was just confused, okay. So the formula for CI, making a mistake again. The formula for Cij is -1 power I plus j aij, okay? So aij are these terms, okay? So for example, if we want to want the cofactor of 1, so it will be a, and then it will be -1 plus power I plus j. So for a11, it will be -1 power 2, that is +1. So it is okay. And for this, for 4, it is like 1 and then 3. So 1 plus 3 is 4, so it will be again +4. So the signs will alternate, alternate in this case, okay? So this will be 2 plus 1, so it will be 3, so plus, minus, plus, minus, plus, minus. The signs will alternate over here. So anyway, so we can then convert this 3 by 3 matrices into its cofactors and the minors. Anyway, so this is just for the explanation. Actually, the calculations are very quick. So this will be 1, then that is equal to 1 into -1, sorry, then yeah, okay. So that is 1 into -1, -3 into 4. And because this is going to be multiplied by 0, so that will be 0. So we don't need to calculate. Then the next one is 4 into 2 into 4, minus 0 into 1 or 1 into 0. So what will be this value? -1, -4, -1, minus 12, minus 13. And this value will be 4 times 2 is 8, and 8 times 4 is 32. So it will be plus 32. So 32 minus 13, it will be 19, right? 19. It will be 19. So the determinant of this will be 19 in this case. Okay. Do you have any questions?
For what purpose we use the formula of cofactor?
This formula cofactor. So we are using it
No, under this
determinant.
SIG.
Sorry.
CIG.
Oh, so this one, this one.
Yes, yes.
Actually tells you that how you can determine the sign of the cofactor. How you determine this. So for example, if I plus j is an even number, so sign will be positive. If I plus j is odd number, the sign will be negative. So for example, maybe over here, 4. For this, the cofactor of this will be, because this is the position 3 and 2. So 3 plus 2 is 5. 5 is an odd number, so its sign will be negative. So its cofactor will be -4. So if we want to find the matrix of cofactors over here, so it will be 1, 0, 4, that will be -2, and that will be 1, that will be -3, and then it will be 0, and then it will be -4, and then it will be -1. So this is the cofactor, the matrix of cofactors. Okay, this is the matrix of the cofactors. So this type of concept is later on used for the solution of the linear equations. Okay, cofactors and minors. Any more question? So in this case, we have found out that the determinant of this matrix is 19. Okay, so there is another shortcut method for finding the determinant for a 3 by 3 matrix only. Okay, so for a 3 by 3 matrix, the shortcut method, okay, shortcut method for finding determinants is, it's called SARS methods. Okay, SARS rule. Okay, SARS rule. Okay, it's called SARS rule for a 3 by 3 matrix. So what is this rule? So let's apply this rule to the same matrix for which we have found out that the determinant was 19. So the matrix was 1, 0, 4, 2, 1, 3, 0, 4, -1. Okay, so for the application of this rule, what we will do is we will write it like this: 1, 0, 4, 2, 1, 3, and 0, 4, -1. And then we will write the first 2 columns again: 1, 2, 0, and 0, 1, 4, 0, 1, 4. So for the SARS rule, what you will do is now you will multiply these factors like this in the form of these diagonals, these 3 factors, and then you will subtract out these factors in these form of these diagonals. Okay, and then we will see that we will get the same answer. Okay, so how does it work? So 0, 3, -1, 0, 3, -1. This will be multiplied out. So that will be obviously be 0. And then 4 to 4 plus 4 to 4, and that will be some value, and then minus 1, 3, 4, 1, 3, 4, and then minus 4, 1, 0, so 4, 1, 0. So the last 2 terms will be 0. What is this value? So 32, and then this is 12. So the answer will be 19. Okay. So this is the Saras rule. So this is only applicable for 3 by 3 matrix. Okay. This is only applicable for 3 by 3 matrix. Or you can also apply for 2 by 2 matrix, but that is of course too simple to apply it. For the 2 by 2 matrix, so for example, if we have the 2 by 2 matrix like 2 minus 1, 3, 1. So in order to apply this rule, we will not need to, there will be no need to write one element over here, where there will be just like this. Okay. But anyway, that is too simple. So only for the 3 by 3 matrix, this rule will apply. For the 4 by 4 matrix, this rule will not apply. Okay. Any questions?
I think there is a problem with diagonal, which starts from 0, 3.
Which one? Here?
Yes, I think it must be 0, 3, 0.
Yes, so it is 0, 3, 0. Yeah, 0, 3, 0. Yeah.
Okay.
Yeah, so okay, 0, 3, 0. Okay, you can put it 0. Anyway, it's fortunately it is anyway, it's 0. Yeah, I think because of the, you have to draw it neatly so that we will not make such a mistake. Okay. So that was the Saras rule. Next is, next we can consider some of the properties of the matrices. Okay, so suppose if we have a 4 by 4 matrix. In this case, so if we have, for example, 1, 2, minus 3, 0, 2, minus 4, 2, 3, and then 1, 2, minus 3, 0, and 0, 4, 1, 1. So this is a 4 by 4 matrix, okay? And we can find its determinant by the cofactor method, something like this. So it will be 1, and then its minor will be minus 4, 2, 3, 2, minus 3, 0, and then 4, 1, 1. So that will be its minor. So then minus 2, and it will be, its minor will be 2, 2, 3, and 1 minus 3, 0, 1 minus 3, 0, and 0, 1, 1. And then it will be plus 3. No, it will be 1 minus plus. So it will be actually minus 3. Actually, yeah. Because the signs will go alternately. Plus, minus, plus, minus. Okay. So it should be minus 3. And its minor will be 2 minus 4, 3, and 1, 2, 0, and 0, 4, 1. And then again minus, so that will be, the last one will be 0 anyway. 2 minus 4, 2, and 1, 2 minus 3, 0, 4, 1. Anyway, this will be, anyway, this value will be, anyway, is 0. So we can actually, you can calculate it by the cofactor methods as well. And then finally, whenever you will calculate it, the answer will be 0. The answer will be 0 in this case. And but actually, we don't have to do this calculation in this case to say that it is 0. There is a property of the determinant which says that if two rows are identical, if two rows are identical, then determinant of A, or if, for example, that matrix name is A, will be equal to 0. So in this case, we can see that these two rows, row 3 and row 1, are identical. Okay, so without making any calculations, we can say that its determinant will be 0. And then this, of course, you can verify with the calculations as well. Of course, with the for the length of the time available, I will not do these calculations over here. So the determinant of A will be 0. So this is one of the property of the determinant. Okay, so this is one of the property of the determinant, that the determinant will be 0.
So it's applicable to every two row, yeah?
Yeah, for any two rows. Okay, even if there are 3 rows which are identical, then that determinant will be 0. Similarly, if we have a if we have a matrix something like this, so 1 2 1 3, okay, 0 0 0, and then 1 3 2. If we have the matrix like this, and if any row is 0, if any of the row is 0, then the determinant of that matrix will be also 0. Okay, if any row is 0, then the determinant of the matrix will be also 0. Okay, so the second property is that if any row is 0, that means each element of the row is 0, then determinant of that matrix is 0. Okay. Okay. So, and one more property. If, for example, if we have a matrix something like this, A 1 0 0 0, 4 by 4 matrix, minus 2 1 0 0, and minus 3 2 2 0, and then 1 minus 5 2 3. This is the matrix. So if we have this kind of matrix, and in this matrix you can see that all the elements above the diagonal are 0. Okay, so this is the diagonal. So this is the diagonal, and all elements above the diagonal are 0. So this matrix is called as the lower triangular matrix. This triangle is called as the lower triangular matrix. So the determinant of a lower triangular matrix, or in case of even we have the upper triangular matrix as well. So the determinant of this type of matrix will be the multiplication of the elements on the diagonal. Okay, will be equal to the multiplication of the diagonal elements on the diagonal. So it means it will be 1 1 2 3. 1 times 1 times 2 times 3. So under the diagonal, if you have whatever elements, that will not matter. Okay, so for example, if you have 1 million, 2 billion, or trillion numbers, whatever the numbers under the diagonal will be, the determinant of this lower triangular matrix or for the upper triangular matrix will depend on the elements in on the diagonal, and it will be the multiplication of those elements. So its determinant will be 6. Okay, its determinant will be 6. So this can also even be verified with the calculations, because if we apply the cofactor rule, so we will only have to consider this first one, because if we go along this row, all the 3 other cofactors will be 0. So we don't need to calculate the other terms. So its determinant we can easily calculate like this. So it will be 1 multiplied by the determinant of this 1, 0, 0, 2, 2, 0, and minus 5, 2, and 3. And likewise, its determinant can be calculated, because now it is 1. So this one is the cofactor over here, and then its determinant will be 2, 0, 2, 3. And then from this we can find that it is simply 6. Okay, so this is another property of the determinants. Is it clear?
It's only for lower triangular matrices.
And also for the upper triangular matrix. If it is either a lower triangular or an upper triangular, it will be true. Okay. Okay. So the next property for the determinant is that, so if we have 2 matrices, then A and B, then the determinant of AB will be equal to the determinant of A times the determinant of B. Okay, so this we can verify by taking some certain values. So for example, if A is equal to 4, 1, 2, 1, and B is equal to minus 1, 0, 4, 1, so the determinant of A will be 4 times 1 minus 2 times 1. So it will be 4 minus 2 is 2. Determinant of B will be minus 1 times 1 and minus 0 times 4. So it will be minus 1. So we know that the determinant of A times the determinant of B is now 2 minus 1, that is minus 2. So what will be the determinant of AB? So for this we need to find AB first. So AB will be 4 into minus 1 is 4 into minus 1 plus 1 into 4. Then 4 into 0 plus 1 into 1. And then it is 2 into minus 1 plus 1 into 4. And then 2 into 0 plus 1 into 1. So we get AB matrix as 0, 1, 4 minus 2 is 2, and then we get is 1. So what will be the determinant of AB? So determinant of AB will be 0 times 1. So 0 times 1 minus 0 times 1 minus 1 times 2, minus 1 times 2. So it will be minus 2. So we can see that determinant of AB is minus 2, and determinant of A times determinant of B is also 2 minus 1 is minus 2. So therefore, we also know this property of the determinant. Okay, is it clear?
Yes.
Okay. Okay. Okay, so that's all actually for today. And then there is some more properties of the determinant. So if I have time over this weekend, then I will upload those remaining lecture for the determinants and also for the other topics as well. In the meantime, I have uploaded some tutorials for the Mathematica as well, video tutorials, and then of course for your assignment number 2, some documentary form of tutorials are also available on the Moodle.
Can I ask something?
Yeah. Wait a minute. Maybe I need to stop the